Welcome to another episode of Empower Apps. I'm your host, Leo Dan. Today, I'm joined by Brandon Williams. Brandon, thank you so much for coming on.
Yeah, thanks for having me.
I know a lot of people are fans of your work at Point Free with Steven, but I'll let you go ahead and introduce yourself before we get started.
Yeah, sure. I'm Brandon. I do run a site called Point Free with Steven Salas. It's a video series, educational video series, kind of concentrating some of the more complex and advanced aspects of the Swift language. And we do a lot of open source work. We'll probably be talking about at least one of the libraries today, but yeah, that's the general thing.
So you've got a big talk coming up at Swift Toronto, which is going to be awesome. It is about controlling your dependencies, not letting them control you. And now, initially when I saw that, I was like, oh, it's going to be like about Swift Package Manager, CocoaPods, or something like that.
Yeah.
But in fact, you have a broader and probably more correct definition of what a dependency is. Do you want to explain exactly what that means?
Sure. Yeah, I think anything you probably add into your SPM package, of course you would call that dependency because you're bringing in someone else's code. But I think the definition could be a little bit broader, and it's really just when you have to touch APIs and other people's code that you can't control. And so that would even include Apple's code, right? You don't ever add a dependency in SPM to get access to core location or anything like that. It's just kind of ambiently there, ready for you. But that still is a dependency because whenever you make a direct call to some core location API, you're touching code that you can't possibly control. And that puts you in kind of a compromised position when it comes to running your code in certain situations that you would want to, but it turns out you can't because you don't have control over that code.
And I think that's the key point is that this is pieces of your code you have no control over. So like you talk about core location and how that works. Anything networking, obviously, anything database.
Yeah.
Like even sleep timers and that kind of stuff.
Timers, user defaults. It could be, and honestly, even date generators and UUID generators, all those things that just can extract out new information out of the void. Like when you ask for a new date, you get the current time, all that kind of stuff. Yeah, it can wreak havoc in a code base.
Yeah, that was the part that I found interesting is when you talked about UUIDs and dates, because I don't think of those as you can't control them, but in a sense you do get a wild value every time you call them.
Right. Yeah. Every time you do capital UUID open close paren, that initializer you just get a whole new value of it. And you may not think it's that big of a deal to get a new value out of it. That is the point of it. But it can cause trouble. For that one in particular, it can cause trouble with testing because you may want to assert that some model equals some other model. But if you can't predict the ID that was generated in the first model, then you've got no way of comparing those two as two models together. You kind of have to compare them field by field rather. And then it's on you to remember when you add a new field, you got to go add a new assertion for that new field. Whereas if you just asserted that this model equals this model, it would take care of all of it for you.
Yeah, so let's jump into testing because I think that's the big thing. Well, there's two things you mentioned. Xcode previews and testing is where you run into these issues. You want to go over some of let's start with the testing part since you just mentioned that. What are the particular issues that people will run into when it comes to testing these kind of uncontrolled dependencies?
Yeah, well, so if you start sprinkling in code, like access to location managers, network requests into your code, it becomes very difficult, if not impossible, to unit test. And unit testing is this very particular way of running your code in which you kind of put it in a little sandboxed, isolated execution environment where you need to be able to run it without having spun up a view controller or spun up a Swift UI view. It needs to be just able to run all on its own. And if you reach out to a network request, you have no way of predicting what is the data that's going to come back. If you reach out to some API that loads Mastodon posts, you don't know what's going to come back. And so you have no way of then testing how that data flows through your application. And the point of controlling the dependency so that you can predict what is coming back. It's not so that you can exercise what the Mastodon API is doing. We just have no choice but really to assume that they're going to do the right thing and they'll send us back some post. What we want to test is when the posts come back, how does that flow through our logic? Where does that data get filtered and transformed and put into everything else? That's what we want to test. And you can't do that unless you, in some way, control that dependency.
Yeah, I think that's one of the biggest challenges I feel like people get when they start unit testing is they're like, well, how do I do this with the database? How do I do this with the network? It's like, no. Like, you're not testing that the database works or the networking call works. You're testing your behavior based on what you get back.
Yeah, it's tricky. I think, and a lot of people stumble on that when they're first learning about testing, and I think it can like set you back. If you look at it, you're like, wait, I don't want to test, Apple's APIs. I don't want to test core location. So why would I do this? And that's kind of that's the point, is that to not test those things and to get just to pretend that their API worked the way you expect and it fed data into your thing. But it's very tricky.
So before we get into solutions, let's talk about Xcode previews. What are some things that Xcode previews, like what are some challenges that Xcode previews gives you, different from just what unit tests do?
Yeah, so all right, so well, there's a couple of aspects to this. For the first part, it's the more you compile in a particular project, the bigger chance you have of just breaking previews. And so your first step to improving the stability of previews is kind of break up your project into lots of little modules, and that can greatly improve the stability. Right? So once you've done that, you've got a far more stable preview, but then there are a lot of APIs out there that will just completely break the preview in a couple of ways. First of all, like things like core location. If you just indiscriminately request permissions for location and you use that check to kind of block other things happening in your UI, what will happen is you'll load the preview. You'll never see that little iOS alert saying, do you want to get permission? Because previews do not support that. And I don't know if that's considered a bug in previews or if it's just how previews are expected to work, but you'll never get that little permission box, and therefore you'll just never be able to see in your preview what happens afterwards. And so that just completely ruins that kind of iterative cycle on previews. You're just not allowed to use it. And then there's other kinds of things that just will completely crash the preview, because some APIs require that you have a little info P list in your application that describes why it is you want to access that thing. And that's like anytime you access the microphone, the contacts, even the core location. But for some reason, core location doesn't do this, but other ones do. They will just simply crash your app if you try to access the API without that info P list being there. And so then what happens is you've got your preview and it just crashes. You literally can't run it. And that's honestly just the beginning. Like these dependencies, a lot of them will just make your previews very flaky, not stable, make them inert and functionless, or just completely crash.
So now we're going to get into some like terminology fun here, but the way I've done it, and it's kind of what you kind of get at in your talk, is using mocks, but I might be using the wrong term because there's like 50 different definitions of mock stubs and blah, blah, blah. But that's essentially what I end up doing, is creating mocks. And in some cases, I'll create a special mock for previews or a special mock for unit tests, but it does whatever you tell it to do, essentially, where it's like, oh, here, in this case, give me this lat long, just hard code it, essentially. Or, with networking, like, here, throw this error in it. And that seems like basically what it comes down to as a solution for this kind of thing. Is that correct?
Yeah, that's the entire solution, is rather than reaching out directly to like core location or URL session to load data, you put a lightweight interface in front of it, and then in previews and tests, you can swap out a implementation to put into your feature so that it just immediately returns you some data. And I agree. I don't know whether that's a mock or a stub or a fake or a spy or whatever. I like that zoo of terms. It doesn't really matter, because all that really matters is that we have an interface, and at runtime, we want to be able to swap it in with something that does something a little bit different. Like when you run in the simulator or on your device, you want to use the real thing. You want to use core location. You want to access those APIs. But in almost all other cases, you want to put in something just simpler. Something just, you say, give me the current location, and it just hands you back immediately some lat long, and then your preview will hum right along, and it'll be good.
So in your talk, you talk about protocols is typically the way I've done it, but
Yeah.
you had some reservations about that. You want to explain what those are?
Yeah, well, all right, this is like a long. I mean, Steve and I have been talking about this thing for many years, and protocols are, yeah, certainly the most popular, the de facto way of putting interface in front of something, but it's not the only way. There is this slightly different way in which you can use a struct that has closure properties,
Oh, okay.
and that can substitute in for a protocol for the most part. And in particular, when it comes to controlling dependencies, protocols, you typically just got two implementations. You've got the live one, and then you got kind of like a mock one. And in such situations, the protocols may be a little too high powered, although protocols have gotten a lot of features recently that make this a lot nicer. Like, rewind to early Swift, this struct version was a lot more enticing. Now protocols do satisfy a lot of things that allow this to be easy. But anyway, so if you use the struct interface, it allows you to do some fun things. Like, you get the ability to kind of hot swap out one single endpoint in the dependency for new functionality. So you could like have a mostly live dependency that accesses the true API endpoints, but you just swap one of the endpoints to do something with a mock or something more custom, and that can be really powerful for really sculpting very specific situations that you want to test.
Okay, interesting. What were the things that you were going to mention with protocols that are new that make it more enticing?
Oh, just the fact that we have more of like the existential machinery and
Okay.
the protocol with associated types. That
Types,
stuff,
primary
yeah,
associated types, yada yada.
all the
Okay.
yeah, all that stuff makes it so that it is far less painful to deal with protocols. Like prior to Swift 5, I don't know if that was 6 or 7. It was, to me, it was an absolute no-brainer that you would use a struct for these things. Afterwards, I'm just like, whatever suits your fancy, just go for it.
Yeah.
But I do think there are pros to the struct style. But yeah, it's if you're used to the protocols, then go for the protocols.
Yeah, I think I do protocols probably like 80% of the time, and then the other 20%, if I can throw in a closure and just do it that way, I'll do
Right.
that as
Yeah.
well. If it's simple enough. It's just when I end up having other dependencies, or when I have like the protocol needs to do a little bit more complicated stuff, it's like, yeah, I'll probably end up needing to do a
Yeah.
protocol.
The more complicated the protocol, the more it pushes towards like protocol being the way to go.
Yeah.
But I also say that some of their recent APIs have even eschewed protocols in favor of just simple, like basically bags of closures. Like some
Yep.
of their collection view, like data source stuff, historically that would have all been protocols. You would have made your object or conformed your entire
Delegates,
collection.
probably delegates.
Yeah, delegates. So all that stuff has like slowly been going more towards closure based. So I mean, there's nothing all that strange about it, but you just got to think about it a little bit more.
Right, right. So one of the other things you ran into with testing was the problem with persistence, right? Especially UI testing, where you're like running like a series of tests and something does set some value, then you run the test again, but that value had been set, so now
Yep.
you mess stuff up. Do you like in those cases? I mean, for me, what I typically do is my UI test just ends up resetting it every time it runs, maybe as part of setup or maybe as part of the test itself. What do you see as a solution in those cases?
Yeah, that's the UI test is particularly tricky because it runs in a fully separate process. So even from the XC test file, you get no way to do stuff. Like you can't clear out its user defaults or anything like that. Whatever it does with it, happens in that process. That means you get to add the cleanup code to your actual application project. And the way you communicate between the two is like to set like I think an environment variable or something like that to
Okay.
kind of communicate to your process that, all right, I'm running in a UI test, and then you would set up your dependencies to use like a fake file system, something
Okay.
that doesn't write to the disk, but instead has a little dictionaries mapping URLs to data blobs. And then in the application, when it's like, hey, load me some data from this URL, it'll just give you this data blob. It won't even touch the file system or anything. And so that's the way you typically do it.
But I was going to ask, going back to the talk about protocols and you're mentioning file system, like, do you end up having a protocol for pretty much everything that needs to be like mocked, essentially? So like, oh, URL, you never use URL session, you use the protocol, and the protocol's implementation might have URL session. Is that how you do it?
Yeah, essentially you need an interface in front of each of your dependencies. So
Yeah.
one, whether it's struct or protocol, but yeah, interface in front of your API client, interface in front of your file system, interface in front of user defaults,
Yeah.
database, core location, all those things.
Do you were you ever an Objective C developer?
Oh yeah.
Do you miss swizzling and just being able to change the classes? I
I mean,
don't. I'm not
yeah,
that
yeah,
kind of developer,
yeah.
but I see a lot of older like Objective C folks who are just like, man, I hate how like everything is so strong typed,
Yeah.
and that's like okay, now I see a little bit of the benefit with Objective C.
Yeah, I don't really miss it just because I also remember the terrible things that would happen. When it works great, but like
Right.
it injects so much uncertainty into the rest of your application that's
Yes.
really hard to feel comfortable. And I think other people, maybe people are just better at Objective-C than me. They just had a higher threshold for like understanding that complex system all in their head at once, and
Right.
I struggled with it.
Yeah.
But I think a lot of this pain around writing these dependencies, these like little interfaces, a lot of that pain could probably be mitigated with macros and stuff like that,
Oh,
right?
yeah, right.
So
I figured
like
you were gonna say that.
yeah, so I think we're at least Swift is getting to the point where you will be able to keep the strong types, but you'll also have the tools necessary to put the interfaces in front of them in a lightweight way.
Yeah. I was gonna say macros is pretty much where that tells you where it's
Yeah.
going. Was there anything specific you wanted to mention about testing or protocols or mocking before I keep going further?
Yeah, well, all right. I think one thing I'd like to mention and is that testing, I just don't think is super popular in the iOS community. I think like I also did a lot of Ruby back in the day, and the testing in that community is gigantic.
Yes. Yeah.
And JavaScript's got it. And I think it's a little bit unfortunate. I would kind of encourage people to just dig in a little bit deep to see what testing really means, and this idea of being able to run your feature in this altered like execution context is extremely powerful. The more you're able to do that, all it means is your feature is super isolatable, super decoupled, and can just be understood all on its own, and that is incredibly powerful. And you can only write unit tests if your feature satisfies that. And so regardless, I know it's kind of like, a lot of people have got like really hot takes and unpopular opinions on all these things about testing. I feel like hopefully just look through all that fog and kind of see what testing can do, because I think it's incredibly important. And once you're convinced of that, I think the dependency stuff falls out naturally. You got to do the dependency controlling.
Yeah, I agree 100%. I feel like once you start doing testing, then it's like, oh, okay, now modularization makes a lot more sense. Why do
Yeah.
you think the community is so testing averse? Do you think that's Apple's fault or tooling fault, or is it like, I don't know what Android is like, but I can imagine it might be similar with Android as well. Like
Java's got a big testing ethos and
Okay.
history too. So they do quite a bit of testing also. I really can't give like a universal answer why I think it is, but some things that just come to mind are like basically none of Apple sample code has tests. Like it's none of it. It doesn't
Right.
matter like their Fruta, food truck, Scrum Ding, or all those things. None of them have tests. Now I know Apple does do testing internally, and I know it varies team by team. I know some teams take it extremely seriously, but the sample code, I think Apple's approach with sample code is they like to build fun applications in the absolute simplest way possible so that anyone can kind of just roll in and start messing with things. I think that's their goal with it, because they're making sample code for millions of people. But that doesn't necessarily mean you would go and build your next company, the infrastructure, you'd build it in exactly the same way that Apple does their code.
Right.
It's a learning tool.
Yeah, it's a learning tool, and it's also showing off of this particular API. And
Yeah.
to them, I'm not agreeing with them, but to them, it's like, oh, well, unit tests would just distract away from the fact that we
Yeah.
want to show off Swift data or whatever.
Yeah, and I think it's reasonable. I certainly wouldn't agree that people should be building their applications in the exact way that the Fruta truck was built, but I absolutely understand why they wouldn't add tests and stuff like that. They really just want to show, here are all of our fancy new APIs this year. Here's how to use them. But yeah, I just don't think we can look at Apple as being like kind of the pinnacle. Their sample code is the pinnacle of how you should build these things.
So you mentioned I wouldn't want to build a whole company app around Fruta. And that kind of brings us to like scaling and speed because in the real world, we all work in teams and have to deal with other people and
Mhm.
we have to deal with speed issues with as far as like like you said, if you don't do this, you have to run this crap in the simulator every single time, or you can't even run it in simulator. You have to run it on device, and that just slows things down. Yeah, you want to kind of expand on that, I guess,
Yeah,
and why those are
yeah,
big issues with scaling.
I think what just like with modularization can help kind of parallelize build times and speed up compile times, dependencies can improve developer experience and iterative cycle on things. Because there are a lot of APIs out there that we already talked about, yeah, that don't work in previews, but then there's a lot of APIs out there that don't even work in the simulator.
Right.
If you're making something that
Core
uses the
motion.
gyroscope, yeah,
Yeah.
core motion. If you're using
Yeah.
something that uses gyroscope, that doesn't work in the simulator at all. And so you actually have to run on the device. Now you may be thinking, well, of course I have to run on the device. It's a gyroscope. I want to be able to move my phone around. But
Right.
that's not all testing you do. Sometimes what you want to do is just simulate that the device is being thrown around all over the place, and maybe you've got a little graph that's showing something like. You don't have to take your device and do this. Instead, you could provide a dependency where core motion is pretending like it's doing that. You can have like the little gyroscope meters going crazy all over the place, and that would massively speed up your development cycle. You could even run that in a preview. You wouldn't even have to run it in the simulator. And these kinds of benefits just really start to compound and explode. There is so much that we do as developers that is just kind of working around the quirks of our code base that we've just learned to do it. It's just we've been in the mud for so long that we know that we don't want to ever clean this project because it takes so long to rebuild. We know that we can't ever run this feature in isolation. So I have my little flow of opening up the simulator and I tap, 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 and I get to the feature and I can finally test it. All that stuff starts to kind of peel away when you can just control your dependencies and allow yourself to start up your app in the exact state you want. You don't have to be susceptible to all of that dependency corrupt and everything. You should control all that.
Yeah. Yeah. Sorry, I was like thinking about Apple trying to unit test their like crash detection and how they possibly do that. Do they like throw the phone against the wall or what do they do? Because
Yeah.
yeah, I would hope that they have some mocking system for something like that. Because yeah, like you said, there's all these little quirks that you run into where it's like you need the flexibility of putting something in to replace it.
Yeah. Well, that you bring up an interesting point also is that there's also a bit of a spectrum with this testing too, because you've got the unit test at one end where you mock things because you just want to say, I assume the outside world is doing what I expect, but I just want to test my little nugget of logic. And then at the other end, you've got integration testing where you
Yes.
start to pull in more of the outside world. And that's extremely important. I'm not saying that one side is better than the other. You absolutely should be testing along multiple points of this spectrum. And like this crash testing, I assume they probably do actually have some little laboratory setup where they literally throw phones around. and that's great because, they want to know like when at the end of the day, this thing is working that way. But if then that other thing they want to test is just that an alert pops up with this messaging, I don't think you need to throw the phone across the room just to test an alert.
Right.
You would just, make it fake like it did a crash and then you see the alert. So there's like a spectrum there and you got to test at every level of the spectrum.
Do you think one side of the spectrum is more important than the other?
I do not. No.
Okay.
I think you really need a full around overall testing on all sides of it. You really do.
What was I going to ask?
I will say that certainly the integration side is the hardest side to test, and so typically you've got fewer tests over there because then you can't really make absolute assertions. You can't say, oh, I made this network request and I got this exact thing. Instead, you can just say, oh, I made this network request, it fed into my system, and I can assert that at least something happened, but I can't assert that exactly what happened because you can't predict it. But yeah, integration testing is far harder than unit testing.
So I think now we can jump into the muck that is how do we deal with all these dependencies. So the way I watched your Try Swift Talk or New York Swift Talk, excuse me, and
Stevens, right?
no,
or was it my talk?
It was your talk, yeah, in New
Oh,
York.
the one from like in April. Yeah, yeah.
Yeah, sorry. So I watched that and I was like, well, my solution is supply default implementations that are the real thing, and then in your previews and then in your tests, you just you
Swap it up.
customize them, right? That's the way I do it.
Yeah.
But you don't like that. And I liked it. Well, you had a really good quote that I saved. Defaults are ergonomic but not safe, and requirements are safe but not ergonomic. Do you want to explain that?
Yeah.
I guess.
Yeah, yeah. So the easiest way to provide dependencies to your various features is you have an initial. Well, you hold the dependency as a property in whatever your thing is, a view controller or observable object, and you provide an initializer that has a default, which is the live thing. So the thing that makes network request, or the thing that actually accesses core location. And that way, if you construct that feature and don't provide anything, it gets the live dependency and it all seems really good. And then over in previews, you get the opportunity to then provide one of those mock things. All right, so that can be a really good way to get your feet wet and start getting things going. And it's very ergonomic because it means you could have some deep leaf feature. You could be drilled down multiple levels into your application, and you could be like, oh, wait, this feature now needs a network client. So I'm just going to provide that default, everything compiles, it's all good. So that's super ergonomic. You get to add dependencies with no trouble whatsoever. However, I call that not being safe, because what it means is, say some other feature up the hierarchy also wanted a network client. All right, if it doesn't pass its network client down to every feature along the way so that leaf feature gets the exact same one, then you run into the situation where you could be running a preview of that parent feature. The parent feature is using the mock network client, but that leaf feature is using the live one because no one passed it all the way down to the leaf feature. And so that's why it's unsafe, that you will accidentally use live dependencies when you don't expect it, unless you're strict with yourself to pass them explicitly along.
That's what I mean, that's kind of what I do. I would just pass them along. I would still supply the default, but I would pass it along. But I understand where you're coming from completely.
Yeah. Yeah, the default gives the ergonomics, but it takes away the safety, because then it's on you to remember to pass along, because the compiler can't help you. If you don't pass it, it's like, well, you got a default, no big deal. So that's where the safety part comes in.
Macros save us, please.
Yeah.
Yeah. So I mean, essentially, what you get, like, I like that solution. And part of that is I don't want to have to add another dependency, which is kind of what you get at, is having to add some sort of dependency injection library. And I'm actually, in my previous life, we used when I was a .NET developer, C#. We did used it was Castle Windsor, I believe, was the dependency injection tool, and I thought it was awesome. Like, it was amazing how it worked, and like I wish, and I think maybe macros actually might help with this. As far as dependency injection is concerned, but basically, like, there's a plethora of library, and of course, you at Point Free you have one as well, that kind of try to solve this problem. I know what dependency injection is, but I'll let you go ahead and explain that, and then what these tools actually do and how they kind of fit the role that you think is better than the way we suggested with defaults.
Sure. Yeah. All right. So if you go down the route of finally controlling your dependencies, and you provide initializers to pass them in explicitly, and you find that to be non-ergonomic, so then you throw in some defaults, and then you find that to be not safe. The only point of adding a library to this entire system is to find a balance between something that is pretty ergonomic and also pretty safe. You'll never have the fullness of ergonomics and safety at the same time. There are trade-offs. Yeah. But initializers that don't have defaults are extremely safe, not ergonomic at all, and then initializers with defaults are extremely ergonomic, not safe at all. So you're trying to find somewhere in between those two.
Right.
And that's the only purpose of a dependency injection framework, is allow you to provide the network client and the core location client to the feature that wants it, in a way that's slightly ergonomic and slightly safe. And where you draw the line there is like up to the library. And so we've got our own library. There's probably a dozen or more other libraries in the iOS community. And we try to strike our balance between those two things.
The idea being is like you can say, use this type, and then you tell the dependency injection use this type, essentially, and then basically kind of like a singleton, you kind of resolve it, and then it gives you the type that you had already set. So
Yeah.
is that right?
Yeah. Essentially, you'll have some kind of way of annotating in your feature, like a view controller or observable object, saying this object wants a dependency of this type, and it'll be the job of the dependency injection library to figure out where does it get that thing from, that dependency. And prior to Swift concurrency, pretty much the only way to do this would have been you do have this global singleton of dependencies, and you get to pick from it and provide it to features. But then there would be additional functionality. Maybe you can scope that global singleton to something smaller so that this set of features gets a little bit slightly different dependencies. There's other things you can do, and there's something called containers and stuff like that you can really dive into if you want. But post Swift concurrency, there's now something called task locals, and task locals allow you to have something that looks global, but it's actually quite safe. It can be thread safe, or it is thread safe, and it plays nicely with structured concurrency.
Okay.
And so that's the tool we use to build our dependency library. All of dependencies are basically held in a task local.
What was I going to say? I guess, to me, like the drawback with that is, well, for one thing, do you ever see Apple coming in or and just saying, here's a dependency injection way to do things using macros or whatever? Do you think that could ever happen? Or do you think that we're pretty much going to have to bring in third-party libraries to do this?
I think it could theoretically happen. It would be surprising only for the fact that Apple has never once shown any interest whatsoever in the idea of controlling dependencies. They do not even build APIs that are control friendly. Like, all right, for example, the standard library has some, like, all right, so when Swift concurrency first came out, we had task.sleep, and that was a way to sleep an async context for some amount of time, but that is a completely uncontrolled dependency. If you sprinkle that into your code and then try to test that code, your test will just literally have to wait for time to pass. So if you needed to wait 10 seconds before something happened in your feature, like confetti or something, your test would have to just wait 10 seconds. So then in the next kind of update to Swift concurrency, they released the clock protocol, which is an abstraction and interface in front of sleeping. And then that allows you to substitute in clocks. You get to use a continuous clock when run on a device, but you could use an immediate clock or a test clock in tests. So that is one of the only examples I can think of Apple providing interfaces that actually make testing easier. Like all their other APIs, core location, core locate motion, context framework, all of those, you just get types. You don't get interfaces in front of those types.
Right.
So that's why it would be surprising to me if Apple came out with some wonderful way of doing dependency management. Now, however, I'll say Swift UI is, from its very foundation, a gigantic dependency management system, essentially. Like environment variables and environment objects, that is all about how do you take something and push it deep into a view hierarchy. So we've got the tool at the view layer, but I think that was probably out of just pure necessity of wanting the idea of, like, if you set a foreground color on this view, the fact that it needs to be able to trickle deep into the view hierarchy. I think that drove that necessity. It wasn't that they were like, oh, we've got dependency clients we need to control, therefore we need the environment value. I don't think that was their line of reasoning.
Right.
And so what our dependency library, what we take inspiration from the environment values, and we try to give a tool that looks like environment values, but you can use it in observable objects and stuff like that.
I was wondering if that was like a limitation of NS, or not NS object, but Objective-C, and like they're like, yeah, we're not going to do, because we can do a bunch of other stuff we had talked about previously. But then I'm like, yeah, all these new Swift APIs are all like you said, not protocols or interfaces. They're just
Yeah.
types like Swift data. It's all strongly typed.
Yeah. Yeah.
So yeah, I kind of, yeah.
Yeah, I can definitely buy the argument that Apple didn't really ever see a need for dependency management control and stuff like that in Objective-C Day because everything was so loosey-goosey with message dispatch and stuff like that. I don't know what their plan is for Swift. I don't know how people within app, like the people building the weather
Have
app
you ever
and the
like
stocks
looked
app
at
and
any of the open source stuff and seen how they do it? Like
what open source do they have?
I don't know, like foundation or collections or algorithms.
Yeah,
or,
so those are like foundational libraries that don't benefit from this kind of thing. It would be like if they ever open source the weather app, I'd be very curious how they deal with things in the weather app, something like that.
Right. Yeah, I think we covered most everything. Was there anything else you want to talk about before we jump into DubDub at all?
No. I mean, maybe something will come up, but nothing comes to mind right now.
Well, so I was going to ask, more focused on WWDC, like has any of, well, let's start with the Swift UI and observation stuff. Has that changed any of your views as far as how dependencies should be managed? Or is it pretty much, oh yeah, it's all the same? Because there was a lot of stuff, with like property wrappers that essentially are kind of like not needed anymore because of observation. Has that changed any of your views on dependency management when it comes to especially Swift UI?
It has not changed any of the core views of dependencies, but the observation tracking stuff does open up new powers we could possibly give a dependency library, like our library, or anyone can add to the library. So one of the things that we do with our dependency library is that if you start using it in your feature and then you write a unit test for that feature, and you don't override the dependency in the test, you get a test failure the moment your feature even accesses the dependency. So, if you get like a method that says the load data button tapped, and inside there you go into your network client and you're like, oh, load data, that will trigger a test failure because the opinion of our library is that if you accidentally use a live dependency in a test, that is most likely not the thing you want to do.
Right.
And so we complain really loudly saying, you're using a live dependency, you probably don't mean this. If you do mean this, you can be explicitly and say, I do mean this, but by default, right? And so then there's so we force you to override that dependency, and we have a tool that allows you to write your test where you get to override the dependency. But there's a flip side to that where if you construct your model in the test and you override all its dependencies, but say you override too many dependencies, there is the idea that maybe that should be a failure. If you override dependency that wasn't actually used, maybe that should be a failure because then you get to trim down the dependencies you override to the bare minimum. And that really allows you to prove that you know how this feature is working.
Yeah.
And that kind of being able to have that insight of what dependency endpoints are being used and which ones are not being used, I think all the observation tracking will help with that. And that's a completely non-Swift UI application of that tool. Just the idea of the observation in general, I think will be it's just going to allow us to build some very interesting tools. But the idea of controlling dependencies, observation alone doesn't really change that story.
Right. How about as far as like using macros?
Macros just will make finally controlling your dependencies more ergonomic, and maybe using our library more ergonomic. But yeah, it doesn't change the reason to do it or not to do it. It just makes it.
But now you have
a little bit nicer.
Syntactic sugar to spread around to make it a lot easier to do.
We can make for example, like registering a dependency within the library so that you can start using it in your features. It is a multi-step process, just like with environment values. You have to create this like little environment. Well, for Swift UI environment values, you create an environment key, you conform it to a protocol, you extend environment values, you add a computed property.
Right.
There's a chance all of that could be macroified and a one-stop kind of thing.
Have you jumped into creating your own macros yet?
Yeah, we've experimented with quite a bit, mostly for our case paths library and composable architecture and stuff like that. Yeah.
Pretty easy, comfortable getting into swim syntax and stuff, or what?
Swift syntax is a beast. It's,
I know it is.
Yeah. And you really need autocomplete to help you every step of the way, because it is so much there. There's like this AST Swift Syntax Explorer website that allows you just to paste in some Swift code, and it prints out the Swift syntax code alongside it, so you can kind of just see what every little thing corresponds to, and that helps you learn what the heck is going on. But yeah, Swift syntax is a beast.
I'm glad you said that, not ChatGPT. That's good.
Oh yeah.
And then last but not least, Swift data. Where do you see that fits in as far as dependency management is concerned and mocking that? I mean, I guess you've already had stuff with core data, which of course is a dependency as well. That's certainly a wild card. Is it kind of the same way with Swift data?
So what? Yeah, it's basically the same story. I think Swift has, so it's really just to enter like a nicer API on top of core data. As far as I can tell. So I think that story is the same. But so one thing that's interesting about core data, and I think I misspoke a little earlier when I was like, I'm trying to think of examples where Apple has made APIs that are control friendly or testable friendly. Core data actually does have a little bit of that because it has the concept of the in-memory store. So you know, usually when you're running in the simulator on device,
you write it to a SQLite file.
Yeah, and there is the option where you get to say, all right, well, I want to load up my application, and I don't want to use that SQLite file. I just want to say I want it all to be in memory. That way, when the application is killed, no data was persisted, and that can be incredibly helpful for UI tests and unit tests and stuff like that. So that's a really good tool, but that's the same story regardless of Swift data or core data. That's just kind of been carried over. So Swift data, to me, I don't know of anything special about it that changes dependencies. I mean, the most special thing about it is just how it plays nicely with Swift UI. Like because you know, historically, if you threw a reference type into a Swift UI view, just in the most naive way, none of its changes would cause updates to the view. And now we've got the machinery that allows you to throw in a reference type and you make a mutation to something and it does update the Swift UI view. So that is big, and I think that will be highly applicable outside of Swift data and observable objects. I think you will be able to, like you could have the idea of one of our @dependency property wrappers could potentially hook into that so that you could actually use it in the view, whereas typically right now you use it in the observable object or the view controller, but there are other places I think you could start using it.
Anything else you want to mention before we close out? Any sneak previews of new point-free stuff?
Well, yeah, I mean, let's see. Today, so next week, we're releasing 1.0 of the composable architecture. It's been in development for like 4 years. And so that's a big release, and yeah, all the observation and macro stuff, it really fundamentally changes so much of what we've always wanted to do with the composable architecture and what wasn't really possible. And so there's a lot of big stuff there, and yeah, we've got this Swift dependencies library. Just github.com/pointfreeco/Swift dependencies, and we've got links in the README to all the other dependency libraries out there, because I'm in no way saying people should go and use ours. Like we have made some very particular decisions in the design of our library that makes it so that we can't even do some of the things that the other libraries can do.
Right.
But then the flip side is that we can do some things that they can't do. It's just there's trade-offs all over the place. And so I highly recommend people go look at those libraries. But yeah, we've got our own version of the library. And so I encourage people to check it out.
Great. Brandon, thank you so much for coming on. It was good to have you.
Yeah.
Where can people find you online?
It's mbrandonw on Twitter, and then also on Mastodon on the Hackaderm instance. Yeah.
Awesome. And then of course Point Free. We'll have links to that as well. People can find me on Twitter at LeoGDion. My company is Bright Digit. If you're watching this on YouTube, please like and subscribe. If you're listening to this, please post a review. Thank you so much for joining us, and I look forward to talking to everyone again. Bye, everyone.
Thanks. Bye.